Ya, Assalamualaikum warahmatullahi wabarakatuh. My name is Nick Fazarul Hakim bin Kamal Rizuki and my metric number is CD240138. Okay, today I want to present about our fluid mechanics project. Okay, now we just go to the 1.0, which is introduction. Based on the slides, I will summarize the content in an easy to understand. This project titled DIY Smart Water Dispenser for Plants. Use an Arduino Uno and YF-S201 flow sensor to water plants automatically. Okay, it helps solve the problem of inconsistent or forgotten watering by measuring how much water flows and turning off the pump once the right amount is given. Okay, this ensures each plant gets the water it needs without waste. Okay, we go to the second point. Okay, from a fluid mechanics point of view, this project helps us understand the concept of flow rate and how to measure water volume. It shows how sensors and simple coding can be used to control the movement of water, making it a practical and eco-friendly solution for daily plant care. Okay, next we move to the 2.0, which is a background theory. Based on the slides, I will summarize the content in an easy to understand. Okay, this project use basic ideas from fluid mechanics, which is the study of how water move. One key concept is flow rate, which means how much water flows in a certain time. By controlling the flow, we can make sure the plants get just the right amount of water, not too much or too little. Okay, the second point is the YF-S201 flow sensor works by counting how fast a small turbine spins as water flows through it. Okay, this spin sends signal, which is pulse, to the Arduino Uno, which then calculates the water use. Okay, when the set amount is reached, the Arduino Uno stops the pump, and this makes the watering system smart, simple, and efficient.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Ilham bin Mukhtar, CD24003. Okay, for this time I will present about the design process. So this is our project circuit. First we can see the battery is connected to the water pump, and then we have Arduino Uno, and then the one is YFS201 flow sensor, and then the jumper wire is to connect all the components. Okay, this is the functions of the component we use. The first one is YFS201 flow sensor. It is to measure the water flow rate using an internal rotor mechanism. Second is generates electrical pulses proportional to water flow. Then to sense data to Arduino's via signal pin. The last one is powered by Arduino's 5V and GND pins. The second component is Arduino Uno. Is it to access the main controller of the system. This is to count pulses from the flow sensor to calculate flow rate and total volume. Then is does not control the water pump in this setup. The last one is powered separately via USB or battery, but for this project we use the battery. The third component is water pump. Water pump is to pushes water from the reservoir towards the plant. Then is it powered directly by a battery, not controlled by Arduino. Then the last one is delivers water continuously as long as battery is connected. The fourth one is battery. Battery is for pump. Is it dedicated power source of the water pump? connected directly to the pump's terminal and then ensures continuously pump's operation without Arduino involvement. Okay, the last one is jumper wires. This is to provide electrical connections between the components. Then is to connect flow sensor to Arduino. Then the last one is connect battery to water pump, positive and negative terminals.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Iman bin Muhammad Azhar and my matrix number is CD240126. So now I would like to talk about our Arduino coding. This Arduino program is designed to measure water flow from using a flow sensor. It calculates two key things: the flow rate in liter per minute and the total volume in millimeters that has passed through. All of this data is printed live to the serial monitor every second. In the setup section of the code, pin 2 is used to read the signal from the sensor. It sets as an input with an internal pull-up resistor. We also attach an interrupt to pin 2 to continue the pulse accurately using a function called pulse counter. Pin 8 is configured as an output, which could be used to control something like a relay. And finally, the serial communication is initialized at a speed of 9600 baud to send the flow data to the computer. Alright, in the loop section of the code, the logic is simple but effective. First, it resets the pulse count. Then, it enables interrupts, allowing the sensor to count pulse for 1 full second. After that, interrupts are disabled so we can safely calculate the flow. The calculation is based on the sensor spec, which says that 7.5 pulse equal to 1 liter per minute. So, the flow rate is pulse count divided by 7.5. Then, the flow rate is used to calculate how much water has passed through, converting it into millimeters, then adding it to the total. Finally, the program prints both the current flow rate and the total volume to the serial monitor, so we can see the data in the real time. And onto the next slide, you will see the full code image. Everything I have just explained is shown here, from the setup to the loop and calculations. So you can connect the explanation directly with the actual code structure.
Next, we go to experimental method and setup. System setup and initial procedure. Project goal is develop a DIY smart water dispenser for plant with precise control. Core principle: evaluate system performance by integrating fluid mechanics with an internal control system. Key component: first, Arduino Uno as a brain, YFS201 flow sensor, flow measurement, DC water pump direct to 9-volt battery, measuring cylinder calibration, verifications. System setup: component form a complete fluid and electrical circuit, fluid part, reservoir to pump to flow sensor, next dispensing point. Uh, next Next, electrical connection, flow sensor signal to Arduino digital pin 2, pump direct power to battery and external 9-volt supply. Initial procedure: assemble and wire component, meticulously upload Arduino control code, perform initial system check, field receiver, power on, monitor real-time data over min via serial monitor.
Assalamualaikum, we are from group 4 and this is our project simulation. In this setup, we are using a 9-volt power supply connected to a water pump. The water flows through a flow sensor and the data is processed by an Arduino microcontroller. The real-time flow rate is displayed on the LCD screen. This simulation demonstrates how the flow rate varies when powered by a 9-volt source. Overall, the project ran smoothly and as expected. Thank you for watching.
Alright, Bismillahirrahmanirrahim. Assalamualaikum. My name is Afi Irfan bin Jamhuri. My metric number is CD240321. And today I would like to explain about our result and analysis. Right, so as we can see at the slide, these tables show a comparison between the theoretical and actual performance of our pump system. Right, so first we supplied 9 volt to the pump, which is above its rated 5 volt input. This overvolting increases performance but should be managed carefully. The expected flow rate was calculated as 2.7 liter per minute, assuming ideal scaling from the original 5 volt performance. However, our actual measured flow rate was slightly lower at 2.53 liter per minute due to real-world inefficiencies. To deliver 500 milliliter, the theoretical time was 11.1 seconds, while the actual time was 11.85 seconds, just a small difference. The resulting flow rate error is about 6.3%, which we consider a minor deviation and acceptable for this application. Overall, our system performs close to the theoretical expectations, validating our design with only slight real-world variation. Right, thank you. Alright, so we continue with the analysis for our result just now. Alright, so our pump operates efficiently at 9 volts, delivering performance very close to the theoretical expectations. The actual flow rate deviates by only 6.3%, which is considered minor. This small difference is likely caused by internal tubing resistance, slight inefficiencies in the pump when overvolted, and voltage drop under load. Despite these real-world factors, the system remains well within acceptable engineering tolerance. This confirms that our design is not only optimized but also reliable and practical for real applications. Thank you.
Assalamualaikum. My name is Ilya Natasha. So in this part, I want to present about discussion on accuracy. So for the YFS201 turbine flow sensor, for the overview, this low-cost turbine flow sensor that is widely used in educational and hobbyist project to measure the flow rate of liquid. It operates by allowing liquid to pass through a small internal chamber where a rotor fitted with magnet spin at a speed proportional to the flow rate. Inside the sensor, a Hall effect sensor detects each rotation of the rotor and sends digital plus signal a microcontroller such as Arduino. These plus signal are then converted into a flow rate using a calibration factor, which is usually defined in terms of pulses per liter. This makes the YFST01 is a simple and accessible tool for measuring flow in a basic system. And however, while it is easy to use because it is affordable and important to understand that this is a sensor designed mainly for non-critical application where high precision is not a major concern. So for the problem with YFST01 is not very accurate, only about 10%, which may be acceptable for simple experiment but not for precise measurement. This sensor is highly sensitive to the type of water flow. If the flow is turbulent or contains air bubble, the rotor may wobble instead of spinning smoothly. So how to make it better or way to improve the accuracy? Use the straight pipe before and after sensor for smoother flow, and add a software filter to smooth the data. Using a length of straight pipe before and after the sensor can also help to produce a smooth laminar flow, which reduce turbulence and improve measurement reliability. Software filtering technique such as applying a low pass filter or moving average can help smooth out short-term fluctuations in plus reading caused by unstable flow or electrical noise. And the lastly is keep the sensor clean from the dirty or a leak. Next, for the improvement in this project, first one is moisture sensor calibration. This is to improve accuracy. The soil measure sensor should be calibrated properly using both dry and wet spoon. Different type of soil can produce different reading, and sensor can lose accuracy over time. By calibrating the sensor and setting a custom threshold in the Arduino code, the system become more reliable. Also, averaging multiply reading in the code can help reduce the effect of sudden function or noise. The second one is better water flow control. Currently, the water pump will release too much or too little water. Adding a solenoid valve or flow sensor will help regulate water flow more precisely. This ensures that plant receive just the right amount of water, neither too much or too little. The three is power backup system. One major issue is the system only work when power is available. To solve this problem, a battery backup or solar panel can be added, especially for outdoor use. This also the system to continue operating during power outage or when placed in remote area. 4 is remote monitoring capability. Right now, user must be physically near the system to check its status, but integrating a Wi-Fi or Bluetooth module, the system can send update to a smartphone or computer, and this enable real-time remote monitoring of soil measure and watering activity. 5 is water level monitoring. The current system does not notify the user when the water tank run out. Installing a water level sensor can help detect low water level and alert the user in time to refill the tank. This prevents the system from running dry and falling water the plants. 6 is weather protection of the system. Outdoor components should be protected from rain, heat and dust, and placing the electronic in waterproof box help extend the lifespan of the system and ensure safe operation in harsh condition.
Okay, last but not least, we just go to the 9.0, which is conclusion. Based on the slides, I will summarize the content in an easy to understand. Okay, this project use basic fluid mechanics, which is the study of how water moves. It focuses on flow rate, meaning how much water flows in a certain time. The YFS201 sensor measures this by counting the spins of a small turbine as water passes through. These signals are sent to the Arduino Uno, which calculates the water use and stops the pump once the set amount is reached. Okay, this makes the watering plants automatic, smart and efficient.